Looks like some people are reporting some lag issues. Sorry about that, folks. Yeah, I think I'll just take a second and try to fix this. Alright, hopefully that'll improve some things. And get that. Alright then. Let's see, where were we? Do let me know if that glitchiness or whatever continues, and I'll maybe see if there's something else I can do. Sorry for the interruptions. Right. So we were writing this delete dupes function, and let's just see where we're at with this. Cool. All right. So we just iterate through the key value pairs. We have a scene vals, so this just turns into an accumulator pattern, sort of, where we're accumulating in one instance, and in another instance we are just deleting if V is already in the accumulated vowels. Cool. Let's see if I can get this to sort of. It's very interesting. Oops. That is interesting. So the order does seem to be being observed here. Huh. All right. Well, that's that. There you go. Cool. All right, copying a dictionary. I kind of cheated for this one because I used copy here. Maybe I should. Should I rewrite that though? No, it's fine. Let's just copy this. So copy. I guess if you've used copy with lists, the idea is the same with dictionaries. We don't want to write functions that mutate their inputs. No, actually, this previous function does mutate its input. Let's check this out real quick. What I mean by a function mutating its inputs is, like in this example, this is challenge 2. Try to remove. We take in a dictionary, a key name, and then we have this pop, which if it's true, we return. If it's not, if it's false, then we just remove and don't return. And if the key isn't in the dictionary, then we return not found. So under these two conditions, we're actually removing the dictionary or the key from dictionary. Any pros or cons? We got a question here. Any pros or cons of accumulating into a new dictionary rather than a list? Any pros or cons? I mean, I guess the way I would answer that would be it's very circumstantial. They each have different benefits. Lists can be sliced. Lists and tuples can be like sliced since they're ordered, and dictionaries can't be. But dictionaries can also be very fast. It might seem like they're like a heavier data type, but the hash lookup algorithm that dictionaries use to look up keys is a very efficient one. Be considered an advantage, I guess, of dictionaries. Accumulating, yeah, I guess I would say not really. I just wouldn't think about it as like pros or cons. Just think about like how do you want to model your data. What sort of data structure makes sense to model one thing or another. And I generally tend to err, like if I think, oh, I could use a dictionary for this, I'll take a step back and I'll think, can I use a list? instead. And the reason is I tend to err on using simpler types before complex types, and if I think I can get the job done with a list, I'll use a list. Yeah, I guess that's sort of my rule of thumb, but really you just kind of play it by ear, figure which type is going to be best suited for whatever you're doing. Yeah, I hope that helps. I know that's a little vague, but if you have a follow-up to that question, feel free to pop it in. All right. Yeah, so just a quick note on this mutability of inputs. This function, let's look at this here real quick. I'm going to run this. Okay. So this takes in a dictionary and a key and this pop, which is true or false. So dictionary and key. This dictionary has 3 keys in it outside here, right? This dictionary has nothing to do with this function that we're writing. It has absolutely nothing. It's just a completely independent little piece of data. But if I print it here before we call the function and pass the dictionary, oops, we're going to see we get the whole dictionary out. If I print it after the function, we can see this dictionary has been shortened. This is an anti-pattern. This is a bad practice in general. I think you will find people out there who will say, no, this is fine. I'm just gonna go ahead and take the risk and say that they are objectively wrong. This is not really fine. There is code out there that works like this, and it's awful. It's really hard to deal with this kind of pattern. Because you have data and then you have things that just alter it sort of without asking, or without being able to predict. I could see this, maybe you could make an exception on the basis of, like, if this dictionary was really massive and you were going to pare it down significantly by passing it to a function and trimming it. But I would probably say mutable in the name somewhere. That's what I would do, but just make the name of the function clear that it's going to actually alter the data passed to it. You can also see there are methods in Python that do the same thing. Yeah. Dang. I'm not sure what to do. Not sure what to do. We're getting some bad connection information again. So I'm just gonna keep rolling and hope it recovers on its own this time, just so we can get through as much of this as possible. Sorry about the inconvenience, though. Actually, let me just see if I can adjust this real quick. Okay, I'm hoping that's gonna stabilize things. Sorry if it's not gonna work. Alright. Cool. That's enough about my mutability spiel. I realize I make that spiel, that whole thing, I make that whole speech. Probably a lot of you have heard me say that already. Cool. So that brings us to copy, which is nice because it helps us not mutate our inputs. So copy, let's just go straight to the challenges. No, let's look at how it's called first. Okay. This is copy a dictionary. Example, and that'll be, let's say, oops, D1122. So if I say del, we'll say, oops, D copy. Oops, equals d.copy. So if I change, this is called a deep copy, by the way. If I change something about D, if I say D sub 1, and 1 in this case might look like an index in a list, but it's a key instead of an index. Say del D sub 1, and I print D. That's what we expect. You know, we expect D sub 1 to be altered. Let's actually look at this. We'll say D deep copy and D shallow copy. Shallow copy is going to be this. So if I print so we'll print the original dictionary, which is the one we altered. So original dictionary D is the one we altered. And then we print the shallow copy, which is just D shallow copy equals D. And D deep copy. So we can see that whatever we do to D is reflected in D shallow copy, but it's not reflected in D deep copy. And the reason for this is because these two variables, D and D shallow copy, they point to the same exact piece of data in the program, right? So they literally point to the same dictionary. And we can prove this if we print the ID. So if you look at these two numbers, it's kind of hard to tell at first, but if you look from the right to the left, that's where the variance is going to happen. Often the left-hand side will be pretty much the same for the first 4 to 8 or whatever digits, but the last few digits will be different, and that'll tell you that the ID is different. So if I print the ID of deep copy, that'll show us that it actually has a different ID. And yeah, you can see these are all the same for the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For the first 12 digits are the same, and then the first two in 627
and the deep copy ends in 912. So that tells us it's actually a different ID. So when we make the copy, it's just a different dictionary that happens to have the same key value pairs in it. So that's how you can think about that. Cool. Why do you think you shouldn't just use D subcopy or D copy and equals D syntax? Because we told you to. Because everything that you read about programming is right, and because it is about a technical subject, because doing so would only copy the keys of the dictionary D. That's not the case. It'll copy the keys and the values, but it doesn't really copy the dictionary. It just makes another variable that points to the same dictionary. Because doing so results in two variables referencing the same object, which in and of itself is not bad, but where it really comes to bear is that if you mutate one, you mutate the other, which is probably not as useful as you think. Okay, referencing the same object. Recall that an object in a section of memory that holds a value, and therefore changing that object using one variable would change the object associated with the other variables, since they are the same object. Yes, that's the one. Good. Yeah, so that can be kind of a confusing thing. If you think you made a copy of something like this, and you make an alteration to either the copy or the original, and the change shows up in the next one, that can be kind of a confusing pattern. Cool. All right. So what will be printed from the two print statements? Okay. What will be printed from the two print statements? dict1 equals dict2, id dict1 equals id dict2. Okay, so dict1 is 1, 2, 3, 4. Dict2 is dict1.copy, so it's going to have a different ID. Dict2 sub 5 equals 5, dict1 sub 5 equals 5. Okay, so they are going to have the same key value pairs. So their values, the value of the dictionary, meaning all of its key value pairs, is its value, are going to be the same, but their IDs are going to be different. So the values, which is what's being checked in this first one, is going to be true, and the IDs is going to be false. So let's test that out. Oh, I already copied that in. True and false. Okay. Oops. Looks like I already did that one before. All right.
So in the block of code below, do the following steps. Do I need this? Person one. Okay, whatever. Do the following steps. Use the assignment operator to make a copy of person one. Okay. I'll do this. I think initially all we had was this in here. Actually, I'll just do this. I'll work out of the terminal. We'll just pretend like that answer isn't there. Okay, so use the assignment operator to make a copy of person one and person two. Okay, so person two will be a shallow copy. Person two equals person one. And we'll just say shallow copy. Now we'll say add a key called job status to person two. Person two. So job status. Oops. So job status equals true. Uh-oh. Oh, sorry. That's checking for equality rather than setting it equal to. Alright. So person two sub job status equals true. Use the copy method to make a copy of the person one dictionary in the variable person three. Okay, so we'll say person equals person dot copy. Okay. Then delete job status key for person three. Del person three. Sub job status. All right, let's do this. And we will let's print these out. Oops. 1, 2, 3. So it looks like 1 and 2 are the same, and 3 is different. So let's see what we get. And you can see actually had slightly different code here. Cool. So that works. Let's actually do this one. Let's look at this one too. So this one I actually remember helping a student with this. We played around with the order of these. But in this case, I just copied person 3 from person 2 before I added job status to person 2, which adds it to person 1 as well. So that way I didn't need to delete. So this gives us the same result, but it actually follows a different set of steps. And both work. Cool. Dictionary accumulators. All right, this is the good stuff. All right, so by the end of this lesson, we'll be able to implement the accumulator pattern. Implement the accumulator pattern with a dictionary. Understand how different dictionary values can be set to different objects. Yeah. I like to think about dictionary accumulation like there are sort of two categories of dictionary accumulation. There are sort of two branches of it that are distinct in my mind. So let's check these out. Well, sorry, this is the dictionary accumulation. Okay. So we'll say two branches. Two branches. One is where you're accumulating keys and value pairs, like key value pairs. So okay. Another is where you're using the keys themselves as whatever kind of accumulator they are. So let's call that value. Oops. Yeah. Let's call it a value accumulator, and let's call it a key value pair accumulator. So you have a key value pair accumulator and a value accumulator. So these would be kind of good shorthand terms for the way that I think about this. And hopefully you'll see what I mean here in a second. So first let's look at the accumulating key value pairs. So let's say I want to write a function that is going to, let me come in here. I'm going to just copy in some filler text. Okay, so this is just a little bit of filler text. This is a famous poem that probably some of you will recognize. So let's say I wanted to have a dictionary to give me the frequency of like occurrences of different words. So I'll just call this text. And we'll say word frequency dict. We'll print this out. And we'll pass the text. Let's call it my text. If I can hit the keys. Good. Okay, so my text is going to take in text, word frequency def, word frequency d takes in text. Okay, so what I want to do is I want to accumulate, I want to go through text, and I want to accumulate into a dictionary something of the form word number of occurrences, or we can just call that frequency. word, and then the frequency, which will be an integer. And the word will be a string. str actually. Cool. Okay, so first of all, we have to make a for loop for word in text. So in order to get an instance of every word, I'm just going to split. If I pass nothing to split, it's going to assume to split on spaces, new line characters, and tab characters. And that's the best way to get an instance of every word. In this case, we're going to get punctuations and capital letters. Or actually, I can remove capitals really easy. We'll just do dot lower. And oh, of course, right. Word. Okay, cool. So these do have punctuation marks in them. For now, those are like sleep comma and sleep period are going to be two different words. We're just going to have to deal with that for now. I don't want to make a whole string cleaner function. I could go through and clean it up if I can, but it doesn't really matter that much. All right, so what we want to do is we want to accumulate into a dictionary. So D equals an empty dictionary. We want to accumulate keys and values. So this is an example of the first branch, of the first kind of a dictionary accumulation, where we're accumulating both keys and values. Okay, so what I want to say is D sub word plus equals 1. Now, this is going to give us an error because notice I say plus equals. So plus equals has to have something, it presumes that D sub word already has a value, which it doesn't. But this is sort of the heart of what we want to do. We want to add 1 to whatever D sub word is. So when you're accumulating keys and values, or when you're accumulating keys, you can do if whatever you want your key name to be. In this case, we want our key names to be word. So if word in D, and we can leave it there, but I'm going to say d.keys because I think it's helpful to be explicit about that. Then we're going to say D sub word equals 1. And there are ways of doing this where you set it equal to 0 or whatever, but I'm just going to start mine at 1. And then else, oops, I think I made an error. If D sub word, or excuse me, if word not in D sub keys, D keys, I don't know why I keep saying sub. So if word not in D keys, then we want D sub word to equal 1. And this creates a value. This puts in a key value pair that was not in dictionary before. If it is in D keys, and let's just write this here, right? If word is a key in D, word is a key in D, then we're going to say D sub word plus equals 1. And this is going to alter the existing value by adding 1 to it. Cool. And then of course we want to return D. Okay, cool. So there's our word frequency. So this is an example of key and value accumulation. This might be maybe the closest to other forms of accumulation in that, like, you're starting with an empty dictionary, which I guess you can do. You know what? This is an example. This is actually an example of both. This is an example of where you're using you're accumulating keys here, key and value here, and then you're using the keys themselves to be accumulators, right? But it's a little hard to see. But generally, when you're accumulating keys and values, you will have this sort of, if whatever you want to be your key is not in the dictionary, then you're going to add it in. If it already is in the key, if it already is in the dictionary, then you're going to do something else. So this is this if-else sort of pattern, checking if your key exists in the dictionary and adding it if it doesn't, and then incrementing a given key that already does exist. This is a pretty common pattern. Okay, so what about just accumulating values? A lot of times when you're doing this, let's see, I'm trying to think of an example. A lot of times you're starting with a dictionary that's already populated when you're accumulating values. So let's say I'm trying to think what would be a good let's say apples 0 and bananas. Gosh. Okay. Bananas is also 0. That's good enough for now. So let's just say we want to like count fruits and we have a list of let's just say apple and bananas. Apples and bananas. And we're just going to go and count how many apples and bananas we have. Okay. So we'll say 4 fruit in list. We'll just say if fruit, there's a quicker way to do this, but I'm going to do it the long way. If fruit equals apples, d sub apples plus equals 1. If elif, I could just use an else, but elif fruit equals bananas. Oh my gosh, I left out a bunch of comments. What is wrong with me today? Elif fruit equals bananas. Bananas, d sub bananas plus equals 1. Okay. So this is an example of just accumulating on values, right? Because these keys essentially act as their own accumulators, right? So if I print five apples and 2 bananas, that's not right. That's extremely confusing. 1, 2, 3, 4, 5. 1, 2, 3, 4. Am I? That should be 5 and 4. That's really weird. Okay. Oh. That's what it was. Yeah, okay. I left it come out there and it didn't know what to make of it. All right. Cool. So yeah, this is sort of categorically the two different examples of the two ways to accumulate to a dictionary. So we have the first one, which is key value pairs. This is actually an example of both, but generally you're doing both when you're doing key value pairs. But you can also treat the values themselves like accumulators. And these could be lists too. We could change this to be lists. So instead I could do .append. And .append is not a feature of a dictionary. It's not a method for a dictionary. It's a method for a list, but this is a list. D sub apples is a list now. And the same here. Let's just do good. All right, so we get our two different lists this way. Okay, cool. Oops. There we go. Okay. So let's just see what this explanation is about. So recall that an accumulator is an object used to collect and store the result of operations within a loop. So the loop executes each of its iterations concurrently, and or not concurrently, serially in series. And each time it goes through the loop, some set of conditions or operations is performed that leads to the accumulator being altered or not. And when the loop is over, then the accumulator will have a new value. All right, so more simply put, an accumulator is typically a running total or a quote collection of objects held inside an object, such as a list or a dictionary. The dictionary can be a uniquely good accumulator because it can use specific keys and in essence hold multiple accumulators. So it's good when you want to you have different categories that you want to sort things in. You can have each key be the sort of category. Using a dictionary accumulator, you can accumulate both the running total, i.e. the count of occurrences, or a list of new occurrences. So you can, if you have like multiple accumulators for a problem, which is totally fine to do it, you may want to use a dictionary to collect those all together. That can be a useful thing. Okay. The next few examples will show just how useful dictionaries can be as accumulators. So assume a list as an input. Let's just look at the code. So list A, B, C, A, B, A, C, B, C, C, A. So we're going to start our accumulator dictionary. And this is sort of an example of the second type of accumulation that I showed, where we start with our keys. We know what all our keys are going to be ahead of time. So we just template those in right away. And we have our 3 accumulation targets here, right? So we say for value in list, if value is equal to A, then we D sub A plus equals 1. If value is equal to B, then we D sub B plus equals 1. Else, then we D sub C plus equals 1. And print it out. Let's run that code. Let's try it out. Say example 2 here. Cool, so we have 5 A's, 3 B's, and 4 C's. Nice. So here we can see that the list is filled with characters A, B, C. It can also be seen that using a dictionary allows one to keep track of the frequency of each character inside of one object instead of doing it using 3 different variables or lists. So we could have done this, and this is actually, let's just deconstruct this. We could have done something really similar if we had like, actually I'll copy this whole thing. If we had like A equals 0, B equals 0, C equals 0, right? And then we would sort of do the same thing. Here. Cool. 5, 4, and 3, right? So this would be similar. You could do that too. Suppose you could also do this. I'm going to pull this 2.2. And then at the end you could say D equals a dictionary A, 1A, B, B, C. Good. To do that, and then we would have a value for D, right? It occurs to me that you can do this in this instance. I haven't seen code like this, like where you're accumulating on variables and then you pop those into a dictionary later. this will work, but it's not conventional. What is conventional is the original way, where you start your accumulator dictionary with a sort of zeroed out dictionary, and you can accumulate directly onto that. And I'll just take a note here. Unconventional. Okay. This is some interesting code. What? Okay. Oh, example 3. Okay. Yeah, cool. So here we just start with a list of a range. Let's see, where are we using list? Just in those two places, it looks like. So I'm actually gonna just remove this and just pop that right into where we're using list. Oh no, I'm not gonna butcher it. Fine, I'll leave it alone. So we have our list, which is a range from 0 to 60 in steps of 4. So actually that goes to 59 instead of 60. We start our accumulator dictionary, and then we run through that range. So for val in list, if val mod 3, so if the value is divisible, if it's a multiple of 3, or if it's divisible by 3, then we will append the val to the 0 key. If the value is divided by 3 and has 1 left over, then we append it to the 1 key. Otherwise, we append it to the 2 key. And then this will give us a list of values over that range, and where each value is going to fall. So 0, 12, 24, 36, and 48 are all mod 3 equals 0, 4, 16, 28, 48, 52 are all mod 3 equals 1, etc. So that's pretty cool. Again, those are examples of the second type that I showed. The second type, let's call it a value accumulation. Okay. Creating a dictionary, creating this, okay. Oops. Example 4. Example stir. I see. Oh, I missed that line, that's why. Okay, so this is going to lower, it's going to clean out all the periods, and it's going to split on spaces. We're going to start an empty dictionary, and this is an example of key value accumulation. So this is basically what we did before in that first function. So if I, let's just print D at the bottom. Yeah, so this is just going to give us a word frequency. So that's key value accumulation. All right, let's see how many of these we can get done. So this will be, these are round of challenges. Challenge 1, write a function, blah, blah, blah. Actually, yeah, no, I'll do it. So write a function called Accumod5 that does the following. Creates a list containing all the values between low and high inclusive, going by 4s. Okay. Returns a dictionary with keys representing all possible results of in mod 5. I see. Mod 5 where n is every number in the list created in the previous step. Okay, so the value inside each key, I need to come back to that second one. The value inside each key should represent the number of times that that modulo value occurred when in mod 5 is applied to every number. Okay. The list. Use a loop to fill dictionary with the appropriate counts. Note the keys should be integers. Keys should be integers. Okay, cool. So this gives us a little bit of output. So I'm just going to see if I can make a test real quick. These are not valid syntax, so we'll just delete them. And, oops. We'll comment that out. Okay. So, D equals an empty dictionary, and I know I'm going to have a for loop for num in range low, high, +1, and it said steps of 4, so I'll do 4. Print num. Okay. I'm going to format this a little differently just so I can read it. Okay. Cool. So 0, 4, 4, 4, 3, 4, 2, 4, 1, 3. Good. So return the dictionary where the keys represent the results of in mod 5. I think this is the n that they're talking about. And so we'll say d equals d sub in mod 5 equals I think this is just plus equals 1. So we need to say if in mod 5. Oh, come on. What's with that? Mod 5 in d.keys. Then we will add it. So that means we'll do equals, not plus equals. Else we will, nope, did that backwards again, not in d keys. Okay. Now I want to return d. So 0, 4, 4, 4, 3, 4, 2, 4, 1, 3. 0, 4, 4, 4, 3, 4, 2, 4, 1, 3. Cool. Alright. I'm going to try that out. Good. All right, and that puts us right at time for today's stream. Sorry about the technical difficulties. If you have any follow-up questions about the material we covered today, just DM me and I'll get back to you as soon as possible. I recently moved house, so I'm just dealing with a lot of catch-up right now, so I may be a little bit of a delay before I can get back to you. But yeah, I plan on doing some study halls. Tovio and I will start trading off on these, I think, more frequently. Yeah, the technical kinks from today will be ironed out as Tovio and I both get used to the new changes with YouTube's streaming studio stuff, amongst other things. I just have other technical issues going on. And, so I promise that those will be ironed out in future streams. So, you're welcome. Getting a thank you. I appreciate that. I'm glad you liked it. Cool. I'm glad. Hope everybody enjoyed it. Yeah, and look forward to next time. So, see you later.